Hello everyone, welcome to statics course. This is the last class of the entire semesters, chapter 9.2, Composite Bodies. So let's start with the last chapter. Today we have one learning goals, determine the location of centroid using the method of composite bodies. Okay, so what is a composite bodies? Here, if you look at the images on the right hand side, then you can see that wall barriers here. And you will see that these are very symmetry, left side and the right hand side relative from the middle, it's symmetry. So you may notice that the center of the gravity or center of mass of this barrier will be in the middle, okay, in the center. So in this case, we can decompose this structure with three objects. If you see here, I just highlighted in yellow. We have three objects, 1 and 2 and 3, and this one is a symmetry. So the center of the gravity of this object should be somewhere in here. Okay, so composite body is consisting of a series of connected, very simpler shaped bodies. So if you think about the ice cream, we can decompose this ice cream cone like ice cream part and cone part. Okay, so if we know the center of the gravity for the ice cream and center of gravity for the cone part, then we can determine the real center of gravity of this whole object, ice cream cone. Okay, so if we already know the center of gravity of each part, each composite bodies, then it's very easy to find the centroid of the whole part. Okay, we don't need to do these kind of integrations or unlimited number of differential areas. We don't need to do that. We have a finite number of areas, so we don't need to do that. But the composite body is not just one body. There are 2 or 3 bodies are connected to each other. So we have to use instead of the integral, we can add sigma. We add up all the area of the composite body and their center of location information as well to determine the real x bar and y bar. So if you remember correctly, last class we learned about how to find the center of the gravity of the whole particles. Okay, so that is the x bar and y bar. X tilde and y tilde, they are different. Okay, x tilde, y tilde are representing the center of gravity of each particle, but x bar and y bar are representing center of the whole particle, whole composite bodies. Okay, so let me show you how to find the center of the gravity of these composite bodies. So if you see these images, we can realize that, it looks like 3 different shapes are connected to each other. Okay, 1, 2, and 3. Okay, now we can determine, okay, so left box is number 1 and the triangle is number 2 and the quarter of a circle is number 3. Okay, and we already know the center of gravity for this rectangular one. The center of gravity of rectangular should be in the middle, and the triangular one, we learned that the center of area of triangle is for the rise part is 1/3 height. Okay, And for this one, for this distance, rise and run, this run part should be 2/3. Let's say this is the width. Okay, so we already know that this information, so that's why we can determine the center of area of this triangle. How about the quarter of the circle? This part should be I didn't explain this one, but based on the definition, it should be 4 times r over 3 times pi. You don't need to memorize this one. If you need to find some centroid of the quarter circle, then you can just simply look at the Google. Okay. So this is the x location and the y location as well. So this is the last step. We already know the centroid of each composite, each bodies, which is 1, 2, 3, and we also know the area of each bodies. So what is the area of this first bodies, which is a rectangular one? 2 times 1.5. That means it's 3 feet square, right? So we also know the area of the second part and the third body. Okay, then we move on. What is the x tilde? X tilde is the centroid of each bodies. So we know that based on our coordinate system, you can see this is x-axis, y-axis, and this intersection point is 0, 0. We know that the x tilde for the first body is 1. Here you can see 1, 0.75. Because this is the rectangular, centroid is in the middle. How about the number 2? Number 2 part, we know that, it's 2.5 from the origin. How about the 3? 3 is a 2.64. Okay, so we also know the y tilde. Then we can multiply the x tilde times the area. So 3 times 1 is equal to 3. Okay, and the next step is y tilde times a. 0.75 times 3, which is 2.25. We do the same things for the second body and the third body. Now what? Now we can calculate all the composite bodies area by adding up all the areas, like 3 plus 1.125 plus 1.767, that's this. Okay, how about add up all these 3 parts? That is this, and the last one is this. If you add up the last column, the 3 values, that should be equal to 1.682, and this one is 10.478. Okay, so like I explained, x bar is sigma x tilde a divided by sigma a. Y bar is sigma y tilde a divided by sigma a. So we have all the information. Okay, so x bar is sigma x tilde times a, that is 10.478 over sigma a, which is 5.892. So the answer for the centroid for the horizontal x is 1.78. For the vertical, y bar is 0.285. So where is the 1.78? 1.78 somewhere, I think here, maybe 1.78. And for the y is 0.285. So where is 0.285? Maybe somewhere here. So this one. Okay, this is the centroid. We do the same thing. We can subtract this white area, which is number 2, from the first one. This is the first one, and second one, and third one. Okay, we do the same thing. So here you can see there is a negative sign for the second bodies. So you also need to do is calculate the add up all the columns values, and just divide by each others. Then you can get an x bar and y bar. Okay, so let's practice with some examples here. This is the last example. Okay. Locate the centroid of the plate area. So we want to find the centroid of these composite bodies. You will see that there are 3 bodies. So first one, so this is the first one. This one is second one, and third one. So you may want to make a table like I show you. Okay, so first, second, third, we want to know the area, and we want to know the x tilde, y tilde, and x tilde times a, y tilde times a. So let's start with the first one. What is the area of the first body, which is a triangle one here? So you know how to calculate the area of triangle. Okay, so it's 3 times 3 over 2, so 4.5. How about the second part? It's 6. How about the third one? It's 1, because 1 times 1 is 1. Okay. Okay, so let's look at the x tilde part. What is the centroid of this first triangle part? We already know that for the triangle one, the centroid should be here. That is, if we set the orientation like this, and the y-axis is here, then we can say that this is 1, 1. I believe you already know this concept. Okay, I will not explain more. You can find directly the centroid of the triangle by applying 1 over 3 or 1 over 2 with 1 over 3 height. Okay, and for the centroid of this one should be in the middle, because this is a rectangular one, and you know, we assume that this is the uniform density. So minus 1, 1.5, because 1.5 is the half point of the height. Okay, so the last one is minus 2.5, 0.5. We can write down here x tilde for the first one is 1, minus 1, minus 2.5. For the y tilde, 1, 1.5, 0.5. Now we can multiply x tilde and a, y tilde and a. So 4.5 times 1. Oh, sorry, not this one. this one. Minus 6. Minus for the y, 9, 0.5. Okay, so let me use other color. We can calculate that sigma A is 11.5 and the sigma x tilde A is minus 4 and sigma y tilde A is 14. So now what? X bar is sigma x tilde A over A, which is minus 4 over, that is minus 0.35. Y bar is sigma y tilde A the 14 over, this one should be 1.22. Since we know the unit, it should be feet. Okay, so you can check the answers here. Alright, today we learned how to determine the centroid of the composite bodies. Thanks for watching this video. Have a great day.